Let's solve this today's LeetCode daily challenge question. So the question is Stone Game 5. Alice and Bob takes turns playing a game with Alice starting first. Okay. Initially there are n stones in a pile. On each player's turn, that player make a move consisting of removing any non-zero square number of stones in the pile. Also, if a player cannot make a move, he or she loses the game, and we are given a positive integer and we have to return true if and only if Alice wins the game, otherwise we have to return false, and assuming both players play optimally. Now let's understand the first question. So what is given? We have how many players? We have two players. Now what we are given? We are given n are number of stones. Now what we can do is at one, okay, in one turn we can remove the perfect square number from that stones. Okay, and if we got the n as 0, I mean sorry, if let's say our x is the remaining elements from n minus y, let's say when my x is 0, in that case whoever's turn is, that player will lose. And what we have to do, we have who are there with us is Alice and Bob. We have to make Bob lose so Alice can win. And if Alice is winning, then we have to return true, else false. So we understood the question. Now, how we will solve? In one turn, what we can do is perfect squares from the stone. So what are the perfect squares? Is they are 1, 4, 9, 16, and so on. Okay. Now let's say example when my n is 1, so who will win is when my n is 1. Of course Alice is starting, it is given in the question. So if Alice starts, it will remove the perfect square 1 from this n. Then what is remaining? My y is in this case is 1, the perfect square, and what is x is 1 minus 1 0. Now I got x is 0 at whose turn? Like Bob's turn. It was Bob. Alice is done with y is equal to 1. Now it is Bob's turn, so Bob will lose, so Alice will win. So our answer is true in this case. Now let's take n is equal to 2. In that case, what we will do is first is Alice, that person will do 1 minus, okay. So y is 1 and x is equal to, in that case it is 1. Next is Bob's. Bob have only one stone remaining, so Bob will also remove the one as it is given in the question. Bob will play optimally. Now my y is 1 and now x is equal to 0. Okay. Now Alice's turn is there and our x is 0, so Alice will lose. So Bob will win. So our answer is false. Alice has lost. Now, when my n is equal to 3, let's take till like good example. N is 3. Alice is playing. My y is equal to 1. Why? Because this is 4 is there na. So we don't have any number greater than 4 till now. So we can't take 4. So these are the possibilities. Okay. Now y is 1. X is what? X is 2. What are remaining is 2. Now Bob's part, when y is 2, sorry, y is 1. What is y? Y is the square I'm considering. Y is 1. X is in this case is 1. Now Alice is there. Y is 1. X is equal to 0. X is what? Remaining. Okay. So total 3 was there. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Now Bob's turn is there. Bob will lose. So our answer is true. Okay. Now one more example we will take is, let's take n is equal to 7. Okay. If my n is equal to 7, initially I have what? My Alice turn is there. Now I have option. What are the option? Is I can either subtract from this is 1. My y can be 1. Also my y can be 4. How and why? Okay. Why? Okay. So my I have total number of stones are 7. So what is given in this question is, we can in one single turn I can remove the perfect squares from the stones. Okay, perfect square stones from the stones. What are the perfect square? 1, 4, 9, 16, and so on. Okay, so I have option of using y is equal to 1, and also I have option of y is equal to 4. Why? Because we have more stones than this number. Can I use this 9? No, because I have only 7 stone. How can I remove 9, right? So I have these two options. So y is equal to 1 and y is equal to 4. Now we'll check. So if I, this is Alice turns, and y is equal to 1 and y is equal to 4. Now here, what was my n? N was my 7. In this case, when my y is equal to 1, what will be my x? X will be 6. What is the remaining? Here my x will be what? It will be 3. What is my x? Is x is equal to y minus n. I'm sorry, x is equal to n minus y. Okay. Now x is remaining, and it is just a temporary. Okay, and we are not using it. Now remaining is 6. Now for after 6, whose turn is there? Bob's turn is there. For Bob's turn, Bob can do, it can also have y is equal to 1 and y is equal to 4. How? Because still 6 is less than 4, right? We are have this 1, 4, 9, 16, and so on. Again I have writing. Now in this case I have only remaining 3. Can I use 4? No, I can't subtract 4 from 3, right? So y is equal to 1 is only option, not this. Okay, now here what will be the x? X is equal to 6. Now my new number is 6. 6 minus 1 is 5. Remaining are 5. Now here my x is equal to 6 minus 4 is 2. Here my x 3 minus 1 is equal to 2. This is my x is a temporary. Okay. Now Bob's turn is done. Now my again L is turn. Now in this case also I have 5. So again my y can be 1, y can be 4. In this case only y can be 1. Here only y can be 1. Now if I have x is equal to 5 and 1, what will be the new temporary x? It will be 5 minus 1, 4. Here it will be 5 minus 4 is 1. And here it will be x is equal to 1, and here also x is equal to 1. Now for my x is equal to 4, again I have option is what? Y is equal to 1. This is now Bob's turn. Y is equal to 1, y is equal to 2, sorry 4, because still 4 are correct. Here my y is equal to 1, y is equal to 1, y is equal to 1. Now when my this will be x is equal to 3, x is equal to 0. Here x is equal to 0, x is equal to 0, x is equal to 0. Now my Alice turn is here. In Alice turn we can see x is equal to 0, 0 and 0 in this case, but still x is equal to 3 is remaining. Okay, when my x is equal to 3 is remaining, what will be my possible y? Y will be 1. Now it will be like, now it was Alice turns, right? It was Alice turn. Yeah, x is equal to, now my new x will be 2. Now my Bob's turn is there. Bob's turn has like y is equal to 1 and x is equal to also 1. When my Alice turn is there, y is equal to 1 and x is equal to 0, and when Bob's turn is there, x is equal to 0. So any one possible. So when my Bob has x is equal to 0, that means Bob is losing. That means Alice will win. Yes, of course, there are these zeros also where Alice will be losing in these cases. In which cases Alice can lose is in these cases. This, okay, and also this one, and also this one. But there is only one possible solution where I can make Alice win. Okay, now if you have seen, these are the options. So when we have the options, in that case what we will do is we make use of recursion. Can't you see this is just a recursion tree? Yes, we are going to optimize it, but still first we will implement this using the recursion, and then we are going to optimize further using the memoization technique. Okay, if you have any doubts, please let me know in the comment section. I'll be always available to solve your queries. Now let's start coding. Now before coding, okay, I want to make sure what will be my base condition. If you have seen, this is my base condition. When my x is 0, what will be? If I'm passing n, okay, if I'm passing, let's say x, if my x is equal to 0, that means I will return what? I'll return false. Okay, whatever it may be, or whichever case it may be. And next, what will be my code is for each, what? For each square I have to check. Till when? Till the n. Okay, so instead of checking I is equal to 1 to n, okay, and finding its square and checking, what we can do is root n. When I is equal to 1 to root n, we will check for each square, any that square will be less than the n, and for each square what we will go through each section, okay, and we will find the this last element, and when we get the answer we will return it. Now what we are going to do is one more thing. So here if you have seen at the last, okay, I have got many this false. Here I got false, false, false. Okay. But any one is one I am getting true. Okay. Anything I am getting true, that means true, I mean this is false. Okay. But when my bob is losing, that means only once it is needed that my bob should lose, rest other I don't care, because we just want to make Alice win. So here in this case only once bob lost, in which case, in this case, and that's what matter. When we find that, we will return our answer as true, because Alice will win. Okay, that remember. Now let's start coding. I'll use another method, because after like when we optimize this solution, in that case we will be needing different functions. So before itself I'll use. So I can use the sol or check anything. Here we'll pass the x. Now if my x is equal to 0, what does that mean? We have to return false. Now here what we will do is for int I is equal to 1, I less than or equal to square root of what? My dot square root of my x, I plus plus. Now here what we will do is we will call the same function it is a recursion. What I should do is x minus, what? X minus I into I. Now what we will check with this, if my this is true, okay, if this is false, if any of the branch bob has lost, that means it will return false, and we have to check the negation, so that if it is true, any of this lost, then what I'll do, I'll return true. Yeah, that's it. Simple. And else we will return false if we don't get anything. Okay, this is simple. So what we have done is we are calling the same function with x minus I into I for each. We have done the same thing here. For each, what we are doing here, if you have seen, here for each, this is what each that means. Okay, this is the different cases, like this and this and this. These are what? 1 and 4 are square. Okay, so for each this I, we will call the same function with this subtraction, and if it is coming false anywhere at the end, okay, it will come from the end, and it will make it negation. So we are just checking it is false, then we should return true. That's it. Now, yeah, that is what we will return here, solve, and now let's run this. So we'll be optimizing. Yes, accepted. You will get the TLE for sure for this solution, because if you have seen, there are many branches with the same numbers. If you see this x1 y1 x1 y1, it is the same. And also if you have seen this y4 and 2 is there, okay, here 4 and 1 is there, but somewhere like the options will be repeated. So if you see time limit exceeded, we are getting. Now how we are going to store this? So simple. Now what we are dealing with, we are dealing with only one parameter, that is x. So if we store the uh, value of that particular x, okay, x can be anything. We have x is the temporary, right? X can be anything but less than n plus 1. X can be n, right? We are passing x as n, so n plus 1. So in that range only. So if we are able to store, let's say I'm considering t as my this, and if I'm storing t of x, if it is true or false, then it will be easy for me to store the state and return if it is already derived. What I'll do is I'll take boolean t. Why I'm taking this boolean wrapper class? Why? Because we can easily uh, check if it is null, then means we haven't derived it, because true or false both can be the value, right? Now here what we'll do, we will initialize. You can also declare here and pass to the function boolean, and what will be the size? N plus 1. Initially all values will be false. So here what I'll check is if my t of x, if it is true. No, I'm not going to check if it is true. If it is not equal to null, then what I'll do, I will return t of x. Why? Because the value can be true or false both, right? But if it is not equal to null, that means it has some value, it is already derived. Okay. And initially, sorry, I think I by mistakenly, if I said if it is false initially, for boolean it will be null initially. Okay, this with wrapper class, if we use the primitive one, then it will be false. Now also we have to update, right? To check this, we also should update here. If I'm returning false, that means t of x is false, that's why I'm returning false. Now here I'm returning true, that means my t of x is true. That's it. So this is what memoization, simply memoization we are using. We are just storing the state. So if it is already derived, we don't need to derive it again. So if you have seen here, what will be x? This is 4. For 4, this is my x is equal to 4. If I have anything x is equal to 4 again, anywhere, okay, no issue. Here if you see, my x is 3. Also same thing here, my x is 3. So answer is x is equal to 0 and x is equal to 0. So if you have seen the same which I am getting, okay, so no need to derive, we are going to get anyway false in that case, in that example I'm saying. Now let's submit this, and this time we should not be getting any TLE. So in this way we optimize this solution. Yes, so we solved using what? Using the recursion. First we approach the recursion. We should understand the question that how we are going to solve this, like why I choose the recursion, because there are choices, right? I can go this way, this way, this way. So my understanding is, if I'm getting a question which has multiple choice, that it should be like this, but doing the same thing, then in that case we should be using the recursion. And if I'm using the recursion, can I just convert this using something like state, managing its state and converting it to memoization? Then I try for that. So this is how it should go. This is how I learned. So this is a good way to understand the question and implement it. And of course there are many solution, like different kinds of solutions are there, like different approach, like recursion is one of them. In this video I solved using recursion plus memoization. So thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you.